Good day everyone! For this Liceo Math Club video tutorial, we will be discussing about basic calculus, the limits of a function using table of values and graph of a function. So first, let us know what is a limit. The informal definition of a limit is what is happening to y as x gets closer to a certain value. The study of limits is necessary in studying change in great detail. Now let's move on to the formal definition of a limit of a function. Now suppose that the function f of x is defined for all values of x near a, but not necessarily at a. If as x approaches a, without actually attaining the value a, f of x approaches the number L. Then we say that L is the limit of f of x as x approaches a, and write the limit of f of x as x approaches a is L. And remember that no matter how x approaches a, f of x approaches L. So how do we find the limit of a function? Well, there are several ways. We have the numerical approach, which is where we construct a table of values. We also have the graphical approach, where we draw the graph of a function by hand or using technology. And lastly, we have the analytic approach, which uses algebra or calculus. For this video, we will be focusing only on the numerical approach, which is creating the table of values again, and the graphical approach in which we will make a graph to illustrate it and to find the answer better. So let's start with example number 1. Example number 1 asks for what is the limit of x squared minus 4 all over x minus 2 as x approaches 2. What are we going to do with this problem? So let's start with the numerical approach solution using the table of values. So we construct a table where there is x and there is f of x. And we had in the problem that as x approaches 2, so 2 should be here in the middle. And then we should have values extremely close to 2 but less than 2 on the left side. And then values extremely close to 2 but greater than 2 on the right side. So basically in the table of values, we are trying to see different values of x that are extremely close to 2 and see what values it yields to f of x, how the changes in values of x will have a change in the results of f of x. And then we are going to observe the behavior from the values to the left, coming from the left, and from the values coming from the right. And then they should have an equal limit to come up with an answer. But if they don't have an equal limit, then it means the limit does not exist, which we will dwell on later on. So first you have that 2 already, and then using the equation that was given in the example x squared minus 4 or all over x minus 2, you plug in the values on the x. So for the 1.9, for instance, you put 1.9 squared minus 4 all over 1.9 minus 2, and when you've computed that, it results to 3.900, and it's rounded off at least 3 places, or depends on the instructions, of course, of the course instructor. And then try 1.99, you make it 1.99 squared minus 4 all over 1.99 minus 2, and then when you solve that and evaluate it, it will give you 3.990. Then you also do the same for the value of 1.999, and the f of x will yield 3.999. And then you will do the same for the values extremely close to 2 but greater than 2, or the values coming from the right of 2 on a number line. And you have 2.001 squared minus 4 all over 2.001 minus 2. It results to 4.001, and so on and so forth. So how do we wrap this up? Let's look at the values at the left of 2 first. We have 3.9, 3.99, 3.999. And if we're going to round that off, then the limit of x squared minus 4 all over x minus 2 as x approaches 2 from the left is 4. Because when you round off 3.999, it gives you 4. And then we observe the values coming from the left. The limit of x squared minus 4 over x minus 2 as x approaches 2 from the right is 4. You get the values of f of x by substituting the values of x from the given equation. And then after that, now you have your left and right limits. And you can see that they are both equal to 4. And since both left and right limits are equal, therefore, the limit of x squared minus 4 all over x minus 2 as x approaches 2 is 4. Now let's try the graphical approach. For the graphical approach, you're going to use the graph of a function, and you can draw it by hand, or you can try different types of technology or apps. You can try Desmos or GeoGebra. So this one is from Desmos, and it shows here you plug in the equation and it will make the graph of that function. And observe that as x approaches 2, the y value is becoming 4. Here it is being emphasized in the graph that the 2 and the 4 meet. Therefore, basing from the graphical approach, the limit of x squared minus 4 all over x minus 2 as x approaches 2 is 4. Example number 2. The limit of x squared minus 5 all over x minus 2 as x approaches 2. Let's try the numerical approach using the table of values. We plug in 2 and then we put the values extremely close to 2 but less than 2 on the left, and then the values extremely close to 2 but greater than 2, and then we get the values of f of x by substituting the values of x from the given equation, which is the limit of x squared minus 5 over x minus 2 as x approaches 2. And we can observe here that the values of f of x from the left, we have 13.900, 103.999, 1003.999, and there's the left limit. The limit of x squared minus 5 over x minus 2 as x approaches 2 from the left is 1003.999. Let's compare it with the limit from the right. We have the values negative 5.900, negative 95.999, negative 9995.999, and the limit of x squared minus 5 all over x minus 2 as x approaches 2 from the right is negative 9995.999. So you can see that they don't come up or approach a common value. The limit from the left is approaching positive infinity, meanwhile the value from the right is approaching negative infinity, which means that they diverge. And since the left and right limits are not approaching to the same value, therefore the limit of x squared minus 5 all over x minus 2 as x approaches 2 does not exist. Let's check the graphical approach. And here we see as x approaches 2, the graph does not touch any values of y. Therefore, the limit does not exist. Now this time, let's practice. Let's test your knowledge and how much you have learned. Try to find the limit of the square root of 10 minus x minus 4 all over x plus 6 as x approaches negative 6. You can pause the video to have time to solve on your own. And when you're done, play the video again to check your answers. Alright, now let's check the answers. Let's use the numerical approach. So, the x value, x approaching negative 6, then you plug in the values on the left side of the table, values that are extremely close to negative 6 but less than 6. So as you notice, it's not negative 5.999, negative 5.99, or negative 5.9 on the left, because in negative numbers, as you go bigger, the value is lesser. And on the number line, you can see that on the left of negative 6, it increases to negative 6, negative 7. So the values on the left should be negative 6.1, negative 6.01, negative 6.001. Then the values on the right, which are values extremely close to negative 6 but greater than negative 6, should be negative 5.999, negative 5.99, and negative 5.9. Then you get the values of f of x by substituting the values of x from the given equation. you get negative 0.12481, then negative 0.12498, negative 0.12500, and then for the right side, you get the values negative 0.12520, negative 0.12502, and negative 0.12500. And observing the limit of square root of 10 minus x minus 4 all over x plus 6 as x approaches negative 6 from the left is negative 0.125. That's your left limit. And then for your right limit, the limit of square root of 10 minus x minus 4 all over x plus 6 is, as x approaches negative 6 from the right, is negative 0.125 as well. And since your left and right limits are equal, therefore, the limit of square root of 10 minus x minus 4 all over x plus 6 as x approaches negative 6 is negative 0.125. Now let's go for the graphical approach. So this is the graph of square root of 10 minus x minus 4 over x plus 6. And as x approaches the 6, the y value is becoming negative 0.125. Therefore, the limit of square root of 10 minus x minus 4 all over x plus 6 as x approaches negative 6 is negative 0.125. That's all. Thank you so much for watching. Have a nice day.